And this is the second lesson this week on reciprocal trig functions. So we're going to be looking mainly at, entirely I should say, at equations today, using sec, cosec, and cot. First, we're going to have a look at these Pythagorean identities. So this was in your learning pack, and that you had to know these identities, but actually you do need to be able to prove these identities. So if we're not trying to prove that 1 plus tan squared x equals sec squared x, we start off using an identity that we know. And we start off using sine squared x plus cos squared x is 1. Now we start off with that identity, and then what we say is, right, we don't want this to be equal to 1, we want it to be equal to sec squared x. Now what would I have to divide everything by in order to make that happen? I would have to divide by cos squared x. Now if I've divided, so that makes that into sec squared x. Now if I've divided this by cos squared x, I need to divide this by cos squared x, and I need to divide this by cos squared x. Okay, whatever we do to one thing, we have to do to everything else in order to make this identity true. So when we do sine squared x divided by cos squared x, we end up with tan squared x, because sine over cos is tan. When we do cos squared x divided by cos squared x, we get 1. And then, as we knew would happen, 1 divided by cos squared x gives us the sec squared x, which is our identity in part A done. So a lot of people, or several people, tend to have problems memorizing these identities. It's great if you can memorize them, but actually if you can't remember them, then you can always start with sine squared x plus cos squared x is 1, and divide everything through by cos squared x. That gives you this first identity. So for the second identity, we're going to do exactly the same thing. We're going to start with sine squared x plus cos squared x is 1. This time, we're being asked to prove an identity using cosec squared x, and we know that cosec squared x comes when we divide by sine squared x. So we'll take the 1 and divide it by sine squared x. That gives us cosec squared x. As before, if we divide one thing by sine squared x, we need to divide everything by sine squared x. So dividing everything by sine squared x in the same way as in the first question, sine squared x divided by sine squared x is 1. Cos squared x divided by sine squared x, well, that's cot squared x. If you remember the lesson yesterday, we use the fact that tan is sine divided by cos. So cos divided by sine is 1 over tan, and 1 over tan is cot. And then we've got our cosec squared x right there on the end. Now what do we do with these two identities? Well, we use them to solve equations. Much like we used sine squared plus cos squared is 1 when we first studied trigonometry, this is now in our toolbox to use to solve more difficult equations. So the first equation that we're going to be presented with is this. Solve for 0 to 360 the equation tan squared x plus 4 sec x minus 2 equals 0. So what's the problem with this question? Well, we have tan and we have sec. And whenever we have more than one trig ratio in the same equation, we need to use an identity to switch one of them out. Now, just the same as when we did the first section on solving trig equations, we go to the squared term. That's going to be the one that we switch out, because our identities all use squares. So which identity do we know that links tan squared x with 4 sec x? Well, it's going to be this one. Tan squared x plus 1 is sec squared x. I'm going to make a note of that just over to the side here. Tan squared x plus 1 is sec squared x. Now, it's always the squared one that we swap out, as I said. So what I need to do is write this identity as tan squared x equals something, because this is what I'm going to substitute in for tan squared x. So here's what happens to the equation then. So we start with tan squared x plus 4 sec x minus 2 equals 0. This tan squared x we're replacing with sec squared x minus 1. And now our entire equation is in terms of sec. And we just collect our like terms and go to solve our quadratic. Now I can see that this one here isn't going to factorize. We can't have two numbers that multiply to make -3 and also add up to make 4. So we use the equation solver on our calculators to get the answer. Again, the examiner is not looking for you to solve by completing the square or quadratic formula. Absolutely not necessary. So we get that sec x is -2 plus or minus √7. So now that we've got two answers, because one with a plus and one with a minus, we solve both of these separately. So if we have sec x is -2 plus √7, a quick check on the calculator just to see what that actually is, -2 plus √7, because we're wary when we solve trig equations. -2 plus √7 is 0.65, okay? And that's going to cause us a problem, because when we go to solve it for cos x, much as we did yesterday, we're going to do 1 over this -2 plus √7. And there's no solutions to this, because -2 plus √7 is 0.65, and 1 divided by 0.65 gives us a number bigger than 1. So we have no solutions. If you attempt to solve that on your calculator, it would just come out with math error or undefined or something like that. So we go to our other solution, sec x is -2 minus √7, and we can do the same check, because we're actually going to do cos x is 1 over this -2 minus √7. This time we will get solutions, but we can do the check, -2 minus √7, and if we use the SD button, we get -4.65. So 1 over that number is going to successfully give us a number between -1 and 1. So we'll do shift cos then, action button, 1 over -2 minus √7, and we get 102 degrees. That's our principal value. I've rounded that to 3 significant figures. And then to find our second value, we'll do 360 minus that number, and we get 258, again to 3 significant figures, and we're done. Those are the only solutions. Now I haven't drawn the cos graph here. You draw the cos graph when you're solving these equations, unless you're getting confident with them and you just know the relationships that cos of x equals cos 360 minus x, and that cos repeats every 360 degrees. So there are solutions. Done. And my last example for today is just another example of a trig equation where we have cot this time and cosec this time. So we need an identity that links cot and cosec. If we go back to our first question here, we know that 1 plus cot squared is cosec squared. So I'm going to write this down. 1 plus cot squared is cosec squared. Now the little rule of thumb we used last time was to take our squared term and swap it out. It's not quite as easy this time, because we've got two squared terms. One of them is cot and one of them is cosec. So you just have to do a little bit more thinking. What one am I going to swap out and why? Well, then we look at our non-squared term, cosec x. We don't know any identities really, other than the fact that it's 1 over sine, that will allow us to get rid of cosec x and turn it into cot. But we do know one that will turn cot squared into cosec squared. And that will allow us to have an entire equation in terms of cosec. So much as we did before, we'll rewrite this identity and say cot squared x is cosec squared x minus 1. And then we'll go ahead and we'll swap that into our equation. So our initial equation is 2 cot squared x minus cosec squared x plus cosec x equals 4. We'll swap in our cot squared x is cosec squared x minus 1. So we've got 2 times cosec squared x minus 1. That's our cot x, remember. Minus cosec squared x plus cosec x equals 4. We'll expand this bracket and collect our like terms together. Well, we'll expand the bracket first, shall we? 2 cosec squared x minus 2 minus cosec squared x plus cosec x equals 4. Now we'll collect our like terms together. 2 cosec squared x minus cosec squared x is just 1 cosec squared x plus cosec x minus 2, and then subtract 4, so we get minus 6 equals 0. So now we can solve, we can factorize, we don't need to factorize, we can see what we get, we can use our equation solvers. So we've got cosec x in brackets then, I'll do factorizing cosec x. And to factorize this one, we've got, let's see, what do we have? We'll have minus 2 and plus 3, won't we? So minus 2 and plus 3. So just to check, cosec x times cosec x, cosec squared x, minus 2 cosec x plus 3 cosec x gives us plus 1 cosec x, and minus 2 times 3 is minus 6. So our two solutions we get are cosec x equals 2 and cosec x equals minus 3. And then we remember what we studied yesterday, in that we can't solve these at the moment, we just turn them into their reciprocals. So cosec is linked to sine, so we just say that sine x then is 1 over 2. Remember reciprocal, okay, so the reciprocal of 2 is a half, the reciprocal of cosec is sine. And this one's going to be sine x is minus 1/3. And we go ahead and we solve these equations. So if we solve sine x equals a half, we get x equals 30 degrees and 150 degrees. Again, using the symmetry of the graph, our limits this time are minus 180 to 180, so we don't need any more than that. For this one here, we're going to have x equals, and just do this quickly on the calculator. So we have minus 19.5 degrees to 3 significant figures. And then if you think about the symmetry on the graph, we're dealing with the sine graph over here. All right, and this is our minus 19.5, so we need to find this solution. So we're going to do minus 180 minus the minus 19.5. Okay, so minus 180 plus 19.5. So we'll do minus 180 minus our answer, and we get minus 161 to 3 significant figures. And that's it. Those are our trig equations using sec, cosec, and cot. Now the key bit, obviously, is knowing your identities. Once you know your identities, you know what you're going to substitute in to solve your equation. And a quick reminder, both of these identities start life as sine squared x plus cos squared x equals 1. And one of them you divide everything by cos squared, the other one you divide everything by sine squared. So if you ever forget or are unsure, it's better to do this quick derivation before you start your equation. All right, there is a worksheet for you. Thanks for listening.